Good morning, students. I'm Professor G. D. Vadil, Assistant Professor, Department of Processing and Food Engineering, KKO College of Agriculture Engineering and Technology, Nashik. So today we are going to study on maximization rate for livestock ventilation. The first important ventilations for livestock buildings for quality of the environment in agriculture buildings is governed by such a factors as temperature, lights, moisture, air quality and movement, dust, odors and disease agents. The environment affects animal comfort and health and ultimately production. It also influences the quality and longevity of stored products. From an engineering standpoint, the environment can be closely controlled. The ventilation process is one of the several methods used to control the environment in farm buildings, where it fulfills two main functions. First, controlling the temperature, and second, controlling the moisture within buildings, means humidity. Ventilation may also be necessary to maintain adequate levels of oxygen and to remove generated gases, dust, odors, and pathogens. But there is a considerable range of ventilation requirements that depend on the local climatic conditions and specific enterprise being served. This is illustrated by following examples. First, cattle shelter in a tropical climate requires little more than shade from roof with the structure located to obtain maximum breach. Second, cattle shelter in cold climate means seasonal frost may be open on the sunny side and provided with a ventilation openings at the ridge and along the rear use. Temperature will be cold. And third, poultry houses with cages in cold climate, if heavily insulated, can be kept comfortably warm, while mechanical ventilation removes excess moisture and odors. The first important is determination of ventilation rates. Okay, means objectives of designing a ventilation system is to determine the ventilation rate to maintain an acceptable temperature as well as acceptable moisture and contaminant levels inside the building. To determine the ventilation rates, heat and moisture balance calculations have to be used sensibly balanced to determine the maximum ventilation rate for summer conditions, while the moisture balance is used to determine the minimum ventilation rate for winter conditions. Okay, so today's we'll discuss about sensible heat balance for determination of maximum ventilation rate for summer conditions. So this is the heat balance equation for determination of maximum ventilation rate. The figure shows sensible heat balance in animal house. Number of sources of heat: lights, motors, heaters, inlets of ventilations, so fluids, waters. Okay. Also, number of heat loss sources from animals. Okay. Steady state heat balance in figure shows requires heat gains to equal heat losses. These are illustrated below. The heat gains are sensible heat from animals expressed in QS, sensible heat from motors and lights expressed in QM, sensible heat from sun QSO, sensible heat from meters QH, sensible heat from the ventilation system expressed in QAI. Okay, these are sources of heat gains in livestock buildings. Then heat losses are number of sources of heat losses. Sensible heat loss through ventilation system expressed in QVO, sensible heat loss through building cells QW, sensible heat loss through floor QF, and sensible heat loss used to evaporate moisture QE. Okay, the sensible heat loss used to evaporate moisture QE is normally included in the QAS term and does not express explicitly. The overall state equation is QS plus QM plus QSO plus QH is equal to summation of AU into C plus FV plus CV into rho into V, bracket complete into Ti minus To. Okay, the where capital U is equal to overall unit area thermal conductance of component in watt per meter square Kelvin. A is area of structural component in meter square. C is equal to path of heat transfer, which may be wall or roof component, and P is building perimeter in meter. F is an experimentally determined perimeter heat loss factor in watt per meter Kelvin. The values of F for an uninsulated and unheated slab flow on a grade range between 1.4 and 1.6 watt per meter Kelvin, depending on how low ambient temperature is. Cp is equal to specific heat of moist air in joule per kg Kelvin. Small r means rho is air density in kg per meter cube. Capital V is volumetric air flow rate in meter cube per second. And Ti into O is indoor and outdoor temperature in degrees Celsius. Okay. The above equation is used to determine the required ventilation rate to maintain given inside temperature for given heater capacity. Also, minimum outside temperature to maintain the desired inside temperature without using supplementary heat at given ventilation rate. And third, the size of heater required to maintain the desired inside temperature for given ventilation rate and outside temperature. Okay. So one of the example for determination of maximum ventilation rate by using heat balance equation. The example is determine the ventilation rate for laying hen house with 30,000 hens having an average body mass of 1.40 kg. The inside temperature is to be maintained at 18 degrees Celsius with relative humidity of 60%. Assumptions also no supplementary heating, no solar heat, no heat from motors. The summation AU and FA factors are 1001 and 272 watt per degree Celsius respectively. Outside temperature is 0 degrees Celsius. Okay. Using the above equations, the unknowns are QS and rho means density. Find firstly QS means yes, sensibility from animals. From table given the sensibility production per bird is 3.9 watt per kg. Therefore, QS is 0.9 watt per kg into 1.40 kg of bird into 30,000 birds per house. Okay, is equal to 1,060 1,63,800 watt per house. This is the sensibility from animals. Then from psychrometric chart with a drivable temperature of 18 degrees Celsius and 60% relative humidity, the specific volume is 0.826 meter cube per kg. The density is inverse of this volume, so that density is 1.28 kg per meter cube. Okay, hence these values are put in equations and determine the ventilation rate. Okay, is 6.4 meter cube per second per house. Okay, thank you, students.